Hello viewers, welcome back to another section of my tutorials, and in this video I'm going to solve double integrals over general regions. When we say double integrals over general regions, it simply means that the limit for your integrals are not rectangular. There may be functions, there may be curves, there may be lines. So let's see the question we have today. It says evaluate the double integral of 2yx squared plus 9y cubed dA. Then the region with which we are going to integrate is y is equal to 2 over 3x and y is equal to 2 root x. You realize that this is a line and this is a curve, right? So once you have this, what are you going to do? The first step for this thing is to make sure that you get the limit for at least one of our variable, and we can directly do that normally from the boundaries given. So you realize that here I have y is equal to this and y equals this, meaning that 2 over 3x is simply equal to 2 root x, right? So once I do this, I'm going to square both sides so that this will give me 4 over 9x squared is equal to 4x, like this. So from here, I can multiply, I'm going to get 4x squared is equal to 36x, right? This will further give me 4x squared minus 36x equals 0. I can then factorize 4x out, x minus 9 equals 0. Therefore, my s is equal to 0 and my s is equal to 9. From here, the next thing to do is to go straight to your Cartesian plane to draw. I'm going to draw. So realize that x is from 0 then to what? 9, right? So once you get this, what you're going to do is you're going to put this 0 and 9 into the function to find your corresponding y value. So when I take y is equal to 2 over 3x, I'm going to put 9 here so that I get y equals 2 over 3 multiplying what? 9. This will go into itself 1 and go here 3. 2 times 3 will give me 6, meaning when y is equal to 9, I'm going to get, when x equals 9, I'll get y to be 6 for the y equals 2 over 3x, and therefore the point will fall here. And when x is 0, y will also be 0, meaning the other point will fall here, and I will join this smoothly. So this is a straight line passing through the origin. So we write the equation y is equal to 2 over 3x. The next thing to do is you're going to take the other function y equals 2 root x. This is a curve, but we first put 0 here. So when x is 0, you realize y will also be 0, meaning it also starts from here. Then when x is 9, you get 2 root 9, giving us what? 6. It will also fall here. So meaning our curve will start here and also end here. But the question is, how or what is the nature of this curve? You are going to take x values within these intervals and see how this function will behave. So when I take x here, which is 4, you realize that when I put 4 here, I'm going to get 2 root 4, which is equal to what? 4. So meaning I have a point 4, 4. When I take another, I won't get any perfect square. So meaning I'm going to have 4, 4. So meaning this function is going to be what? Up. But you first determine if it is going to curve inwards or what? Outwards. And this is the application of differentiation, where we apply the increasing and the what? Decreasing. So you realize that when you differentiate a curve twice and you get a negative, or if the second derivative is positive, then it means you're going to get something like this. But if it is negative, you get something what? Like this, right? So using that scenario, we can easily go into what we are going to do, right? So let's see. If you have y is equal to 2 root x, what are you going to do? My first derivative y prime is going to give me, here will be, this is the same as 2 x to the power half, right? So I'll multiply half by 8. So I'm going to get 2 over 2, then multiplying x to the power what? Negative half. So my first derivative will be y prime is equal to x to the power negative half. Then I'll find my second derivative to confirm. So my second derivative is going to give me what? negative half x to the power what? Negative 3 on 2. Hence, the coefficient is what? Negative. Therefore, I'm going to get a function which will, so here the coefficient is what? Negative, meaning it's going to curve what? This way, right? Sorry, it's going to curve this way rather. It is going to be this way. So you can refer from your maximum and your minimum from calculus 2. So therefore our graph is going to look like this way, like this. Hence I'll have my y is equal to 2 root x here. Then the region with which I'm going to find my intervals is this. Once I've gotten this, I'm good to go. I'll write the question back again. Integral of what? 2y squared plus 9y cubed dA. So right now, looking at this function, it will be easier for me to do what? To slice through y, to integrate y first. It will be easier to integrate y first because here I'm going to get s cubed, or I'm going to get a term which will still introduce a square root sign. So meaning I have to slice through the y since I want to integrate y first. So I'm going to draw a parallel line here and also a parallel line here. Once I draw these parallel lines, you see that the parallel line hits this first, the line first. So meaning our y will be greater than or equal to what? 2 over 3x, but less than or equal to 2 root what? X, right? Yes. So once I get that, I move to the x. The x is simply taken from here to here. So s is greater than or equal to 0, but less than or equal to what? 9, right? Yeah, so for this one, I am done with my limits. So I move straight. Integral of 0 to 9, integral of 2 over 3x, 2 root x, of 2y squared plus 9y cubed dy dx, right? So once I read this part, I'm going to integrate this with respect to y. So I'm going to get y squared s squared plus 9 on 4 y to the power of 4. I'll bring my 2 over 3x here, 2 root what? X. Then integral 0 to what? 9. So I'll bring my dx out. I'm just going to put this inside, this inside. So let's do it carefully. 0 to 9 here. When I put 2 with x here, wherever I see y, this whole square will give me what? 4x, right? Multiplying s squared plus 9 over 4. When I put 2 root x here, 2 with x to the power 4 is going to give us 16x squared. Multiplying 16x squared. Then minus the whole thing, I'm going to put 2 over 3x inside. Okay, so at this point, I'm going to put the lower limit inside. So wherever I see y, I'll put 2 over 3x there. So I'm going to get what? 4 over 9x squared multiplying s squared, then plus 9 on 4. Then here I'm going to get, so I'm putting 2 over 3. 2 to the power 4 is 16 over what? 81. Then all x to the power 4, right? Yes. So I further simplify this and I'm going to get integral 0 to 9 of 4x to the power 3 plus 9 on 4, 16 s squared minus, this place will give me 4 on 9 x to the power 4, then minus 9. So here, let's see, 4 will go into itself 1 and go here 4. 9 will go here 1 and go here 9. So I'll still get 4 over 9. So 4 over 9, right? Yes. So 4 over 9 x to the power 4, like this. 4 over 9 x to the power 4. So now let's keep on simplifying. So 0 to 9, then we come, here is 4s cubed. It's not having any like term here. So meaning I'm going to have my 4s cubed here back. I have 9 on 4, 16s squared. So this is going to give me plus 9 on 4, 16s squared. Then here minus minus, so minus 8 on 9. x to the power what 4 dx. At this point I move straight to integrating this. So 0 to 9. So let me cancel this. When I integrate this, I'm going to get x to the power 4. X to the power what 4 for this place. Then I'm going to get plus. Here I'm going to add 1 to the 2. So when I add 1 to these 2, I'm going to get what? 3. I'm going to get what? 3. So when I get 3, I'll divide through by 3. But first of all, I'm going to multiply here. This is 4. It goes into itself 1 and go here 4. So this place is going to give me 36. So I'm going to have 36, and when I integrate this, it's going to give me 12x cubed, right? Yes, minus, when I come here, when I integrate this, I'm going to get what? 5. So minus 8 on 45, x to the power what? 5. Then from 0 to 9. So at this point, we already have our function integrated. What we are left with is to put our upper and lower limits inside. So when I put my upper, I'm going to get 9 to the power 4 plus 12, 9 cubed, minus 8 on 45, 9 to the power 5, minus everything will be 0, so minus 0. And this is going to simply give us 24057 over 5, which is same as 4811.4. This is the end of the video. Thank you for watching, and don't forget to like and subscribe.